Okay, so welcome everyone. I'm going today to talk about rest in peace. Um, don't worry, nobody is dying during the presentation, at least I hope so. I'm going to talk about some REST APIs here and what we can do to create really great and useful REST APIs for your users. So before I start the presentation itself, let me talk about me a little. So my name is Wendell Adriel. I'm working currently as a lead software engineer at a company called TrackStreet. Um, I mostly work with PHP, Laravel, and JavaScript there. Also Vue.js. I already did some things with Go and Python, but mostly of my daily work is with PHP and Laravel and JavaScript and Vue. So I'm an open source enthusiast, and mostly of my open source projects that I have today are also with those technologies. That's my main stack: PHP, Laravel, and JavaScript. And I've been working with software development since 2009. So it's been a while, and I've been working a lot with full stack development mostly. But in the current years, I shifted more to backend solutions. I still work with front-end and UI for personal projects. Also at my company, I still work with some things, but mostly I've been focusing in backend solutions, and I'm a huge fan of working and creating APIs. So let's go. Um, Let me give you one overview of what's going to be this talk. So first, we are going to talk about HTTP status codes and the importance of using the correct codes for your REST APIs. After that, we are going to talk about HTTP methods and how choosing the correct HTTP method can provide your users handful and insightful information for your API. Using the correct HTTP status codes and the correct HTTP methods, you can create APIs that are really great to use. And we are going to see that during this presentation. Also, we are going to talk about standards and how they are important when creating your API, your REST API. And also, last but not least, we are going to talking about improving your REST APIs without breaking it. And we are going to talk about a little about how to do that. So let's go here and start. So first, HP status codes 101. So there is a lot of HP status codes out there. As you can see, we have a wide range of codes like 100, 102, 2000, 2001, 400, 422. But what do these status codes means, and how we can know that we are using the correct ones for our APIs and our endpoints. So first, these status codes, they are undivided. They are split into 5 different categories, and the status codes that are the 100 ones are informational status. So they are used to provide information about your about the resource that you're calling. If let's for this we can have a lot of different types of clients for consuming APIs. We can have CLI applications, we can have web applications, we can have mobile applications. So when I'm saying client during this whole presentation, it could be any of that. And our API, it's going to be in our server. So when I say that the 100 codes are informational, it's that they provide information the client calls your endpoint and you are returning some information about that specific resource that the client is asking for. Then we have the 200 status codes, and they are success status. So when the client calls your REST API and it works without any issues and it's a success, so you return one of these status codes saying, okay, everything went good. So here is your answer. Then we have the 300 status codes, and they are used for redirection. And what does it mean, redirection? For example, you can have a resource or an endpoint, a resource that the client asks for, I don't know, like um, image, for example, or a page for your web application, but you move that to another place, meaning that that URL, that endpoint, the route was changed. So you use 300 status code to tell the client, okay, you are looking for this resource, but this resource is not here anymore, it was moved somewhere else. So you use the 300 status codes for that. And then we have two categories for errors, and we have the 400 status codes that are the client errors, meaning that, okay, something went wrong. You asked for this resource, but there is something wrong that you sent me. So the, let's say, the error is not in your API. The error is in the client who's asking that. It could be that the client doesn't have permission to see that resource, to get that resource, or it could mean that that resource does not exist, or that the data that the client is sending to your REST API is not valid. So that's some examples of client errors. And then we have the last category, that's the server errors, that are the 500 status codes. And those errors are different because it's still telling the client, okay, there is an error with this resource, but the error is on our side, meaning that the error is in the API, in your REST API. It could be a bad code, something, a bug, an issue in your code. It could be, I don't know, depending on how you treat connections to different service. Let's say that your API connects to another, a third-party service. Depending on how you do that, it could, for example, return a server error to the client, say, okay, there's something error with your request because we couldn't handle we couldn't finish what you asked for. So those are server errors. And now we are going to check some of the most common status codes that we use when creating an API, a REST API. And the first one is the HTTP status 200, and that's okay. That's the most common one. And when you send that information to your client, is telling, okay, you asked for this resource, you provided this information, I already handle everything that's needed, and it's all good, it's okay. So here is your answer, and then we do that. Something that we can see in some APIs, even on big APIs for big companies, it's that they returned the HTTP status 200 okay for everything. So even when it has some errors, let's say so, some APIs, it returns this status saying okay and with an error message in the body of the message. And that's completely wrong because when you send that message, the client it's expecting that message when everything goes okay. So the client is asking you, okay, get me a list of my products that I have in your API, and then we return 200 response back, but then we inside the response we say, okay, we couldn't find or something went wrong with those with this request. So that's not what your client is expecting because the okay status code it's to be when everything is okay with the request that the client did. So please don't send error messages using the HTTP status 200, okay? Then we have the 201, and that's a message for created. And there's a lot of APIs out there that don't use the status code and just use 200 for everything, as I said. And the most common um, place that you use these status codes, the created 201, it's when the user is creating a new resource. So for example, I don't know, I have a blog and I have an endpoint that creates a new post for the blog. So when the user goes there and types the title and writes the post, the article to be published, and it saves, it creates a new post, it creates a new instance, and that would be created, not an okay. Those two are answers saying that was a success, but they have different meaning, they have different context, and context is something that you should give in your API to your users, because it makes your API easier to understand and easier to handle. So when you are creating new resource, it could be anything, for posts, products, new users, anything. When you create a new resource, usually you return created 201 status code instead of the OK one. Now, we also have another one, that's the 204, that's no content. So why we have a code for that? Usually it's signing that, okay, I'm doing this action, everything is okay, but I don't have anything to return to you. So we return the response with this status code, but the response body it's going to be empty. It's not going to have a response body at all. So when we should use that? The most common case, I would say, that's when the user asks for deleting a resource. For example, going back to the example of a blog. I have a blog, and one of the users go there and wants to delete a post from the blog, and they click on the delete button in your web, in your web app, and then you return response with this ATB status 204, but you don't return anything in the response body, because okay, you say it's giving context to the user. As I said before, it's important, the context. It's saying to the user, okay, the action that you asked for, I deleted your post. Everything went okay. It's a success, but I don't have any information to return for that, because we are deleting. So um, it's all good. And the user is going to already, the client is going to understand, okay, I asked for the deletion of this resource and it was deleted. I didn't get any information, but I didn't need that because I already had information about that resource and I specifically asked to delete it. So no need to send any content back. Then we have another common code, that's the 401, and this is for unauthorized requests. And when I use that, well, probably your application, it has login, or your users need to be authenticated to use it, unless it's a totally public application, and those applications are kind of rare nowadays. So usually you have some resource or some things that your users can access only when they are authenticated, logged in your application, in your API. So when a user or someone else tries to access something, a resource in your API, but they are not authenticated, then send this response back unauthorized, saying, okay, you don't have the authorization, you are not authorized to see or get or modify this resource because I don't know who you are. And then we have another one, and that's the ATB status 403, and that's forbidden. And that's kind of like the other one that we saw, the unauthorized, but it's kind of different. The forbidden one is, let's say that you still have your authentication. For example, let's go back to the example of the blog platform, your blog API. You have a blog API, and to create a post, your user needs to be authenticated. So the client can't ask, okay, create this post for me, but not being authenticated because you don't know who is creating that post. And that's 401. But let's say that the user is already logged in your application, in the blog platform that you have, but the user tries to modify or delete a blog post that is not from that user. So the user is trying to delete or modify something that belongs to another user. So instead of using the unauthorized, you use the forbidden, the 403, because, okay, you know who the user is. It's authenticated in your platform, but the user doesn't have access to do that action. It could be a lot of different examples here, but as I said, let's say that the user tries to delete a blog that's not from him. It's forbidden. They can do that because only the owner of that blog, that blog post, is allowed to modify or delete that. So if another user tries to do that, you should say to the user, okay, you can't do that. It's forbidden. So you return this 403 status. Then we have a really common status code, that's the 404, and that's the not found um, code. And this one is really self-explanatory. It's when the client is asking for a resource in your API that doesn't exist. Let's say that the user, going back to the blog example again, the user creates a blog post, then it deletes it. And then sometime later, it tries to access this deleted blog post again. So it doesn't exist anymore. So you return this 404 issue not found because that resource doesn't exist anymore in your API. And then we go to the next one, that's the 422 or 422. It's unprocessable entity. And what this means, unprocessable entity, for a lot of applications, a lot of APIs, this code is used when the user provides data that's not valid. Let's say that your user is that in your blog platform, the user must put their full name, valid email, and a password to register to use your platform. But then the user goes there and provides the name, it provides the password, but provides just a random word for the email. So it's not a valid email. And it sends it to your API. So what should I do? So you should, your API should return a response to your client with this status code, the 422, saying, okay, the email that you provided, it's not a valid email, and that's it. So your client is going to know that it's not that they provided an invalid data for that resource, and they should update this data, meaning that in this example they should provide a valid email for then calling the same resource again. Because if they call it the same resource again with the same data, you should return the same response. So that's the most common case when using this status code. And then we have the 501, that's internal server error. And there is also an issue that I already experienced in with some APIs, that everything is 500 error. So everything is internal server error. And for me, that's the most generic error possible. It can be anything. It's just it's like saying, okay, something went wrong. You probably already saw that message or that response in any API that you consumed, saying, okay, something went wrong. They don't say what went wrong. We don't know what went wrong, but that's how, for me, it's the internal server error. It could be anything. So what I do is I try to avoid the most I can using this error. And this error, I think that it should be used only for specific case or for really, let's say, issues in your code when you don't have, okay, I don't know that this edge case would be possible, so I don't have a code that handles that edge case, that scenario, and then it's going to fail and it's going to say, okay, it's an internal server error, something went wrong. And for the client, okay, we can't say something technical, we can't give internal information about our API to the user as well, to the clients. That would be a security issue. But for people working and maintaining this API, this REST API, they should know that, okay, so this happened. Some today a client asked for this resource and it was returned this internal server error. So something in our code is not working well. We should investigate that. And that's what I think about internal server error. It should be only for these cases that you are not expecting an error to occur. And then we have the 503, that's service unavailable. And this error is really common when we put, for example, an API, a system to maintenance mode. So you put your system to maintenance and you return this status code saying, okay, the service is unavailable now. Usually it also shows if it's a web um, app, it shows a message to the user, something like a page that's something pretty. And depending on how you handle that, you say, okay, we are in maintenance. We expect to be back in, I don't know, in 30 minutes or something. So you should use this status code when, for some reason, your application, your REST API, is not available at the moment, and the maintenance mode is the most common case for that. Okay, so with that, we kind of we went through all the most common HTTP status codes that we have. There is a lot of other ones, yeah, for sure, but I would have just a presentation to talk about those, and it would still be a lot of things that would be left out because there's a lot of status codes that we can use. Those ones that I talked about were the most common ones that we can use during creating our APIs. But make sure to check out other ones because there are others that are really good and really useful for when you are handling errors and also success messages for your API. So please check the other ones. Those are just the most common ones. And now we are going to talk about the HTTP methods. So put your methods to rest. So we have a lot of different methods in REST API that we can use. And the most common ones, as you can see here, is get, post, put, patch, and delete. And then we have four other ones that we don't see much, we don't use much. It's the options, the head, the connect, and the trace. So during this second part of the presentation, I'm going to talk about a little about those. And the first thing I'm going to talk about, it's like the strange ones, let's say. So I put strange because they are not so common. We don't, when creating APIs, we don't create endpoints using those methods that much. And some of them have really specific use cases. So as you can see, we have the options one, and the options method is used to describe what are the communication options available for a specific resource. So the client can send an options request to your API, and you are going to send a response back with like saying all the options, like okay, for this resource you can call it with the get and the post method, for example, saying about the authorization headers and things like that. So it's you send that to the server, and the server sends back the communication options available for that specific resource that you are calling. Then we have the head method, and the head, it acts just like a get endpoint, a get call, a get method, but it doesn't fetch the body of the resource. And why I should use that? Sometimes, in some cases, you don't care about the body of the response. You just care, I don't know, about the HTTP headers of that response. You don't want the content. You just want some headers for that. And to not affect the performance, instead of calling that endpoint, that resource, and getting the whole body, since I wanted just the headers, I can call with the head and get the headers back from the API, but without fetching the whole body of that response, of that resource. And then we have the connect one. And the connect one, it starts a two-way communication between the client and that specific resource. And that could be used to create like tunnels. Think think like a VPN, for example. So that's the connect method. It's not used that much. To be honest, I never used it in any APIs that I created so far. And then we have the trace one. And the trace, the name can be like known to us developers, because we have the stack trace, back trace of errors or something like that, and it's kind of like that. The trace, it when you call a resource with the trace, it returns the full HTTP request back to you. So what it does is it creates like a loop message. You send the request to the client, sends that request to a specific resource, and it goes back to you. It reads the server, and it goes back to the client again with the full information about the sending and the response. So you can use that to debug something. For example, it's really useful when you are trying to debug proxies, or let's say load balancers or something like that. So you could use the trace to check that everything is going okay with your request when it goes out of your client to the server and back to the client again. So it's used for debug information, and use it most for debug information when debugging proxies or load balancers, let's say. Okay, so um, going back to the most common ones, we have the get endpoint, we have the post, put, patch, and we have delete. And the get and the delete ones, they are pretty straightforward, right? The get one you use when you want to get information about a resource, and the delete one you use when you want to delete a resource. So it leaves us to the those three: post, put, and patch. And here goes another thing that a lot of APIs lack. They usually use a lot of APIs use post for everything. So, but why? Because the post is used when that resource receives data from the client and does something, right, with that data. But usually we use the post when we are creating new resources. For example, when in the example I gave back, when the user is creating, for example, a new post blog for their blog, you could create a post endpoint because they are creating a new post instance or another resource that's a post. And then we have the put and patch. Put and patch both are used for updating a resource. So instead of creating a new one, we use it to update a resource. So let's think that, for example, you have that your blog platform, and the user created a post, but they saw, okay, I have some typos or some information that's wrong in my blog post. I need to update it. I need to update, I don't know, the description or the title of that blog post. And then you ask yourself, okay, but so do I use put? Do I use patch? It really depends on each use case, what you're building. Um, the put is used when the user can update the whole resource. So let's say that when the user clicks on edit in your web application, your blog platform, it goes to a page that allows the user to change everything about that blog post, meaning it could update the title, it could update the description, it could update the keywords, the tags, the content itself. So that would be a case for a put endpoint, meaning that the user is able to update the resource as a whole. So that's a use case for a put endpoint. But let's say that you have in your blog platform, you have the list of the posts of that user, and it has also the status of that post, if they are published or not. And let's say that you have a button that's publish for the unpublished posts, meaning that the user doesn't have to go inside and edit your post to make it to publish it. You can just hit the publish button and it's published. So what would that be? It will be a patch endpoint. But why? Because it's updating that blog post, but it's updating just a part of it. It's not updating the whole resource. In this case, it's updating, like, it could be a flag saying, okay, this is not a draft, or it could be just applying the publish date as the current timestamp, for example. And that's updating just a part, in this case one a property of your resource, so it's updating a resource partially. And then you use a patch. It's important to keep that in mind, because if someone is using your API and they know about REST APIs, they are expecting your API to behave like a REST API, following the standards for REST APIs. So if you create an API and everything is a post, okay, if you have that really well documented, the users will not have issues because you have the documentation. But again, they would have to go into your documentation and losing time um, viewing that your API is using a different standard than most of the REST APIs. So if you apply those standards from REST APIs, your users will have much more easy time integrating your API into their application or their work. And then we since I'm already talking about standards, let's go to the third part of this presentation. That's standards matter. And as I was explaining, when your users are using your clients, your users are using your API, your application, they want they want that to be like easy and to integrate. And if they see something in your API, they expect that if the endpoint A is using this way of dealing data, of dealing with errors, or the structure of the response in this way, they are going to think, okay, so this endpoint is doing that. So the all the other endpoints for this API is probably following the same standard, right? And they should, because if you have an API that has different types of how you define endpoints, or different responses structures, or different ways of handling errors, it's going to give a hard time for the users, because they will need to check for each endpoint how to handle all those things, instead of, okay, I know how this API works. I know how it handles the errors. So I can already create an integration for that, and I already know what to expect. I don't have to go every time to their documentation and see endpoint by endpoint what this endpoint is doing, because all your endpoints, all your response, all your errors should be following the same standards. And that's what we are going to check. And the first thing is naming your endpoints. So you could think that this is like a trivial thing, but go here with me and you understand, because the devil is on the details. Um, we have here four endpoints. Let's say that that's this API. It's the blog platform that we were talking about. And then we have four different endpoints. One endpoint for getting the list of users, one endpoint for getting the list of blog posts, another endpoint for getting the recent posts in the platform, and another endpoint for getting the popular posts. But at first hand, if you check that like real quick, you say, okay, that it's all good. There's nothing wrong with those endpoints. And it's it does. It has some issues, because um, that's not they don't have a standard between them. So the first one, we have the base URL for your API. That's HTTPS, the myapi.app, and then we have the endpoint, the route for your resource. And the first one, we have users in the plural form. And the second one, we have post. So you see that post is not in the plural form as users. And here is already an issue, because you are not following a standard for naming your endpoints. And this could be an issue for the users that are integrating with your API, because if they integrate, for example, the user's endpoint first, they'll think, okay, I need to get the list of posts. So probably the endpoint is posts, right? Because we had the endpoint for users that's called users, and they do that and they test and they check, okay, that's a 404. This route does not exist. This resource does not exist in this API, but why? And they go into the documentation and see, okay, so to get the list of posts is slash your myapi.app/post, not posts. So this creates a different way of naming your endpoints, and that's an issue. And the same issue we can see with the recent posts and the popular posts. In the recent posts endpoint, you have a dash for separating the words recent dash posts. And then in the popular posts, you have underline, underscore instead. And if someone is integrating with with your API, they'll have a hard time. Again, they will have to lose time checking your documentation and seeing each endpoint. Okay, how this endpoint name is. Is it using the plural form? Is not using plural form? Is it using dashes, underscore? So if you choose a way and follow that standard in all your application or API, it's going to be much more easy for your users to use it. In this case, personally, I would say use the plural forms for resources. It's much more understandable for your API. So in this case, users would be okay. The post one, I will change it to posts. And it's a personal opinion of mine, but I prefer using dashes instead of underscore for the URLs, for the endpoints. So instead of using popular underscore posts, I would update it to popular dash posts. But it doesn't mean that using underscore is wrong. It's a personal opinion of mine. The only thing that's wrong, it's using dashes for some endpoints and underscores for others. If your API use underscore for the whole API, it doesn't have any problems. It's a personal opinion, so it's all good. But don't mix them because it's going to make hard for your a hard time for your users to integrate your API to use it. And then we have also the standards of how you structure your responses. And here you can see two examples. We have an endpoint that's getting information for a specific user and another endpoint that's getting information of about a specific blog post. And here you can see that they are using different formats. Um, if you look at them, you say, okay, there's nothing wrong. If you look at the user's endpoint alone, you say, okay, there's nothing wrong with this endpoint. And if you look at the posts um, endpoint, you say, okay, there's nothing wrong. But when you put them side by side, like we have here, you will see that there is an issue because they are not following a standard. In the first one, you can see that I'm using the snake case for the properties, for the keys of the properties. You have ID, you have full name, you have email in the snake case. And in the posts one, I have it in the Pascal case. So it's not good because again, your users will have to check the documentation for your API endpoint by endpoint to see that, okay, this endpoint is using snake case, so let's do that. This other endpoint, it's using Pascal case, let's do that. You can even have another one using, I don't know, kebab case or camel case. So again, there is nothing wrong with option one using snake case. There is nothing wrong using option two, Pascal case. You just can't mix them in the same API because it's going to confuse your users. So choose one style and stick with that. Stick with that standard and use it in all your endpoints. And by last, you have the errors, how to handle the errors of your API. So here we have again two different two different endpoints. We have an endpoint that's for creating a new user and an endpoint for creating a new blog post. And okay, you can see both of them are using snake case. That's good. That's already good. But here we have another issue. You can see that in the first example for the user's endpoint, we have two different properties. One property called message and another property called validation errors. That's an object having the email that's where a validation error occurred. So there's nothing wrong here. And then we go to the posts endpoint. And then we have, again, two properties, but we have a property called error and another one called metadata. And then inside of this metadata, we have the validation errors. So, okay, there's nothing wrong with option one, neither have any anything wrong with option two, but you can't have both in the same API, because if a user goes and implements the user's endpoint, they'll check, okay, so when an error in this API occurs, it sends me a message property that I can use to show it to the users in, I don't know, in the web application, for example, in your blog platform. Um, but then they implement the posts one, and nothing is shown in the UI, or some error throws in the UI side, because they were expecting a message property, but you are not sending a message property, you are sending an error property. And this causes, again, confusion, and makes hard for your users to implement your API, because you need to have a standard way of doing things. And in this case, you need to have a standard way of handling and dealing with errors in your application, in your API. Then it's going to be much easier for the users that are using your API to know how to deal with those situations, those scenarios in the client side. And here we go to the last part of this presentation, that's improve without breaking. And what does it mean? So you create your API, you publish it, you created your first product, your first API. But what happens now? Okay, nothing's perfect. We can't create something and leave it there and okay, that's it. So we create it and we have to iterate over it. We have to improve it. We have to fix issues. We have to create new features for that product, that API. And how we do that without breaking the things that are already working there. So the most important thing here with your API is that you need to build trust with your users. And what does it mean? It means that if your API has issues, you have to fix those issues. That's the first point when you build trust. If your users use your API and say, hey, I'll open a support ticket or something and say, hey, I'm trying to do X, but it's not working. Then you need to fix those issues. You can't just, okay, I know there's an issue, but whatever. So you can do that. You need to fix the issues to build trust with your users. They will know that when they find issues, you're going to fix them. You need to provide a reliable API, reliable service for your users. Meaning that, okay, I know that I can count on this API. I know that, for example, if I want to create a blog, I can go to your blog platform and use your API, because I know that it gives me safety to use it, because I know that it's going to work, it's going to be there, it's going to have the issues fixed, it's going to work fast, it's going to bring new things. So you need to be reliable and also provide value to your users. Meaning that, okay, um, you have your blog platform API, but there are another 100 blog platform APIs out there. What makes yours unique? So you need to provide value to your users. And you can't provide value without creating new things, innovating, but you can't do that breaking things that are already working. Because you can say, okay, now I don't know, I have 1,000 users and they use it to do X to create a post. And then you say, okay, I have this wonderful new feature that is going to help you create your blog posts much more easier and consume a lot less time. But X and Y is not going to work anymore. Now you have to do it in this way. Okay, it could be good, but depending on your users, on your clients, they can't have the time to do this change all of a sudden. So you can just create something, improve something, breaking what they are already relying on. Again, your API, your service must be reliable. You need to build trust with your users, knowing that you can provide value, you can fix the issues, can create new things, but without breaking what's already working. And how we do that? One of the easiest ways is versioning your API. So it's the same we do with code, right? It's on Git and we create versions and all. So kind of the same. We can create versions for your API. And with different versions, you can have different features and you can still have things working the way they are currently, sorry, and improving that to your amazing new feature, and the users can start using this new feature when they are ready to, but they can still use it the way it is now. So you provide a reliable way for them to migrate to something better without breaking what they have today. And there are three main or most common methods of versioning your API. The first one is using the URL. So as we said, we can have, for example, my API.app slash v1 slash users. And we can have the same thing with v2. Meaning that, okay, the users can use the version 1 or the version 2 if they want. You can even have a date. Let's say, okay, I released the version 2, it's already ready to use. You can use it if you want, but v1 is still working and it's going to be working for, I don't know, 6 months, 1 year, depending on your use case, on your users. So you can keep both of them working for a while or even keep them both working forever. It depends on how your service goes. But this is one really easy way to do that. Another way, it's using a different subdomain. So instead of putting it in the URL itself, you create a new subdomain. So you have v1.myapi.app or v2.myapi.app. And that's another way. You create a subdomain, a different subdomain here, and if you have, let's say, the trade-offs between the two, um, if you have just one endpoint that you need to kind of break to do something, maybe creating a subdomain for that is an overkill because you have just, I don't know, one endpoint that needs a version 2, so you could go with the URL instead. But if you see that, okay, I need to do a complete refactor of my application because of different reasons, and we need to launch a new version with new features and bug fixes and improvements for performance and etc. Depending on your use case, you could launch a new whole service, a new whole server with your new API and put it in a subdomain like v2.myapi.app. That would make sense. That would make more sense. Also, if you're, for example, switching technologies, sometimes it can happen. Sometimes the stack that you are using doesn't is not giving um, the value that you need. So you need to switch your stacks for some reason. Then you could create a new subdomain to put that new server with this new API version in another server. And another common way is using an HTTP header. So you could still have my API.app slash users, but when requesting that, the client could send an HTTP header saying, okay, the API version that I want to use for this is version 1 or version 2. So that's a good way for doing that without changing your URL. The URL is going to be the same, so the users don't need to to switch for another subdomain or another endpoint. They know, okay, I'm going to hit the same endpoint. I just need to say, okay, I need this specific version, let's say. And you can even have defined that, okay, let's say that I published a new version. I have version 2 of my API. But the default one is still version 1. The version 2 is only for customers that are already ready to use that because there are some breaking changes. So by default, if no one sends anything for this header, they are going to consume version 1. So that's something that you can do, and it's a really good strategy. So there's how you can improve your API without breaking it. So I'm finishing now. It's already a long presentation, almost 1 hour. Oh man, sorry guys, but sorry everyone. I just want to put here, let your CRUD to rest. So thinking about what all the things that we discussed here in this presentation, let's say that I want to create a CRUD for my blog platform, for creating, for managing my blog posts. So how would I create that? So you could create those endpoints. You can have this first endpoint that is going to be use a post method, and it's going to return a 201 because that's creating a new post, and we say that that's the 201 is the created status. Then we have the get endpoint that's for getting the list of posts. You can also use the OK status code, the 200. The same goes for getting a specific post resource. You can have the get endpoint, the get method, and returning the 200 response, the status code. And then we have an endpoint that's to update the blog posts. And you're going to use the put because you can update the whole resource, the whole blog post in this endpoint. So you use put because you can update the resource as a whole. And here you can return or the 200 or the 204. But why? It depends on your use case. Both are valid, both are correct. Depends on when you save that data. Are you returning, for example, the updated instance of the blog post? If so, use the 200 because you are sending back the updated version of that resource. But if you don't need that, like, okay, I'm going to request this update, but I don't need the updated resource back because I already have the updated state here. So I just need to know if it went well. So you could return the 204, that's the known content, and don't return anything in the response body saying, okay, your update was completed successful, but okay, I don't need any more information. And the same goes to the patch. Let's say that, okay, I'm going to create an endpoint that's just for publishing or unpublishing, let's say my blog posts, and it's going to be a patch endpoint. Why? Because it's updating partially my blog resource. And it could also return the 200 or the 204 because I can return the updated resource, the updated blog post, or I can just say, okay, it went well, it was a success, it was updated, but I don't need to return anything more. And then we have the delete endpoint. That's for deleting a blog post. And you use the delete method, of course, because you are requesting to remove to delete. And you have the 204 because you don't need to send anything back. So this here is just a simple, crude example on how to create a REST CRUD the right way with using everything that we discussed here. And guys, everyone, thanks for watching. That's everything I had to say today. I have my personal website that I have a blog there with some articles about mostly about PHP and Laravel, but some things in CSS and JavaScript as well. You can see it here and you can go there, read things. You can also see a list of open source projects that I work and that I contribute to. You can check that in my website as well. Like it, do you like this presentation or not? I don't know. If you have anything to say, any feedback, I would love to hear it. You have here my handle for X or Twitter or whatever you're calling it today. You have it here. So thank you so much and see you next time.